see uh, experiment number 4 from our list from practical list. So objective for this experiment is to understand and implement simple multiple linear regression, to train a linear regression model dataset and evaluate its performance. Is visualize results in graph format and interpret the model coefficients and residuals. Main learning outcome from this experiment. After completing this experiment, as the students were able to explain the hypothesis functions for linear regression and implement linear regressions using Python, scikit-learn, and NumPy library. Preprocesses data and splits data into training and testing two parts. And after that, we can compute the performance metrics and plot the results. The identifying the underfitting and overfitting and basic remedial steps. For this, in this theory, linear regression model, the relationship between dependent variable y and one more independent variable x by fitting a linear equation. What is first of all, you must know what is dependent variable and what is independent variable. Dependent variable, which is dependent on the specific other variable or main variable. If that variable's amount change or number change, then this variables also change. So that this variable depend on other variable. So that is dependent variable, and machine learning is always in y is a more dependent variable, which is result or prediction. This is a target variable. Also, we can say target variable, and one and more independent variable, which is x. If in that machine learning model we give uh, one variable to machine learning model for prediction. So that is a simple linear regression, because we are in simple linear regression, we only give one input for the output machine learning model. In the multiple linear regression, we can give multiple variables for that. In simple linear regressions, for example, if we predict the study, we predict the marks of students, mark score. So for that, we can give first only one input, which is study hours. After this study hours, we can complete, and after that completion of study hours, then we can predict the output of final. What is the what should be the marks for that study hours. So in multiple linear regression, that's marks depends on input of various input like study hours, sleeping hours, mobile hours, and all that very input we give to the machine learning model, and then we receive the output or result for them. For this is the multiple linear regression. In multiple linear regression, this is a formula for the simple linear regression and multiple linear regression. For the loss function usually used for the mean square error, that is the MSE, model fit by minimize error. Error means the actual value minus predicted value. The difference between the actual value and predicted value is called error. In this mean square error is by error square, and its average of that is mean. So it is called as mean square error. Model is fitting minimizing by MSE close to normal equation. And for that, in this practical, we can use for tools Python 3.8 libraries, Jupyter or Google Colab, and libraries for that NumPy, Pandas, Matplotlib, Scikit-learn. So first of all, we need to log in our Google Colab account. So why Google Colab? Because whenever we can log in Google Colab, we can easily access that video from you. And one data set also required for this. In that data sets, we may use any simple synthetic data created with NumPy. The recommended for this is Boston Hosting data set replacement. For the lag example below, the we both simple hours versus score, pre-lab preparations, installation of Python, and procedures step by step. We can now go to the next process in directly which is the practical for coding. So first of all, we go log in our Colab. In this, we can use the new notebook After this new notebook connection, we can create a new notebook page for this Google Colab in this for this experiment. And this experiment here we can see here the coding and text, two types of uh, code here. So first of all, we go to code section. In this code, we can run the all code. First of all, import numpy libraries. After that, we can import which required import import a second library is pandas svd. After that, we can use model selection, import training test split. This library is compulsory required for linear regression. So it is default and the access it is come in here. So SQL linear model import the logistic regression. In this logistic regression, we can access the both two numbers format prediction and also the logistic regression. Next, from sklearn dot matrix, we import mean. What is the matrices used for this? So we here we use mean underscore square error, that also and also R2 square, R2 underscore underscore. That library is also required for this. After that, we can use data set, data equal to data equal to td dot data frame. We can use here insert data point using the concept data frame, in which data frame create the row and column data, and after that we are insert the hours and scores data here. So data frame, in this data frame we can give easily access the data frame concept. With this we use here the hours. First of all, we need to insert gives machine learning model for prediction of marks. We can must go up give to hours for that. Mm, that prediction. So hours, what could be hours in this? Starting from 1.5 hours, 1.5 to 3 hours, 3 hours to 2.5 hours, 2.5 hours, 5 hours, 5 hours. Next, also 3.5 hours, 5 5.5 hours, 6 hours. Next 6.5 hours, 7 hours, 7.5 hours, and also 8 hours for this prediction. So first of all, we give the hours, and next point we must give the score for prediction. How this score will be predicted. So is given the double inverted comma.
म्हणजे नंबर काही सेंबरनं काढलेली काय?
And that model must be fit in this example. So model dot fit dot x dot train and x y train. So after this coefficient, intercept equal to model dot intercept. The coefficient equal to model dot QAP. So for this, we can use your print statement or to print the intercept value and the coefficient value. Intercept value and coefficient value must be printed. After that, prediction and evaluation stage y prediction equal to, which is our prediction for that study hours. Model dot predict x test is the testing data. We can give the testing data to this model. After that, our evaluation matrix MSE mean square error is a function already pre-installed or pre-defined. We can use here the predefined statement with y test and y prediction. So our root mean square either also the function loss function for this, and r2 square r2 square also this the loss function with the evaluation matrix. With the help of this MSE RMSP r2 square, we can find out the total evaluation matrix and find out what is the correct possibilities with this that all this plot in graph. All result we can use we use that plt dot scatter. Because we here see this above, we can use library the matplotlib, which is already a import from here matplotlib library. So that can use your plotting a graph with this x and y axis. This color is, we can give color and data points for labels for that graph, where x line shows x values to 200, and plot line x line is color red, and label for that line is the regression line. What X label is our study and Y label equal to scores. Then let legends is the format for page plt dot show, which show the graph in English. So here we can simply run our code for that, and we can see here after running completion of this, we can see output here. So here shows the output for this intercept equal to weight of one parameters 8.6, and that coefficient equal to mm, 9.8. For that evaluation matrix, mean square error is equal to 3.1547, and root mean square error for that 1.7761. And for R2 score, there is a linear regression. Our score, this is the graph final prediction we are done. First x-axis is our studied show, and y score is score. So and this the linear regression gap, because data points with the actual mass prediction in that regression lines. So if you